Good morning everyone. So today we will start our 6th chapter, which name is Dynamics. So in this chapter we will discuss about what do you mean by dynamics, types of dynamics, there is Newton's law of motion and some derivations. So first of all we need to know what do you mean by dynamics. So dynamics is nothing but it is a branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies in motion. The subject of dynamics may be further subdivided into two types. So the first type is kinetics and the second part is kinematics. So what do you mean by kinetics? So it is the branch of dynamics which deals with the bodies in motion due to the application of forces. Then what do you mean by kinematics? It is the branch of dynamics which deals with the bodies in motion without any reference to the forces which are responsible for the motion. Now, some important terms are there by which we can solve any kind of derivations. So first of all, mass. So what do you mean by that? So mass is the matter contained in a body. The unit of the mass are kilogram, ton, etc. Then weight. Weight is the force by which the body is attracted towards the center of the earth. The unit of the weight are the same as those of force, that is Newton and kilonewton. Then coming to momentum. So momentum means it is the quantity of motion possessed by a body. Mathematically, momentum is equal to mass into velocity. The unit of the momentum depends upon the unit of the mass and velocity. Hence we know that the unit of the mass is kg and the unit of the velocity is meter per second. Hence the unit of the momentum is equal to kg mass per second. Then force. So as we know that force is a very important factor in the field of dynamics. Also, it may be defined as cause which produce or tends to produce or stops or tends to stop the motion. The unit of force is Newton and kilonewton. Then coming to inertia. So inertia means it is an inherent property of body which offers resistance to the change of its state of rest or uniform motion. So here the next term is rigid body. So a rigid body consists of a system of innumerable particles. If the positions of its various particles remain fixed relative to one another, that is known as solid body. And it will be interesting to know that in actual practice, all the solid bodies are not perfectly rigid bodies. However, they are regarded as such since all the solid bodies behave more or less like rigid body. So now coming to Newton's law of motion. So according to the Newton's law, there are three types of Newton's law. As we know that Newton is the father of science. So according to the first law of Newton of motion, it states that every body continues in its state of rest or of uniform motion in a straight line unless it is acted upon by some external force. The second law of Newton, It states that the rate of change of momentum is directly proportional to the impressed force and takes place in the same direction in which the force acts. Then, the third law of Newton, it states that to every action there is always an equal and opposite reaction. So according to Newton's first law of motion, it consists of following two parts. The first part is when a body at rest continues in its same state unless acted upon by some external force, it appears to be self-evident as a train at rest on a level track will not move unless pulled by an engine. Similarly, as an example, we can say a book lying on a table remains at rest unless it is lifted or pushed. Then the second part is when a body moving with a uniform velocity, that is continues its state of uniform motion in a straight line unless it is compelled by some external force to change its state. It cannot be exemplified because it is practically impossible to get rid of force acting on a body. So here a little consideration will show that the effect of inertia is of the following two types. So first step, a body at rest has a tendency to remain at rest. It is called inertia of rest. And then when a body in uniform motion in a straight line has a tendency to preserve its motion, that is known as inertia of motion. So today this much. We will discuss rest of the thing in the next class. Thank you.